It just has to be recognized by people that it's a vital global resource to keep this ice sheet intact. And of course, it isn't at the moment recognized. There has to be some, I think, some pathway where, like the Amazon rainforest, the ice sheets are recognized as global goods that should be protected and supported by the planet everywhere else that benefits by having them not melting.
Hello, and welcome to the very first 2026 edition of the Climate Emergency Forum. I'm Herb Simmons, the author of A Climate Vocabulary of the Future, and I'll be your host and moderator today. And joining with me will be our longtime panelist, Paul Beckwith, who's a climate systems scientist from Ottawa, Canada. He's taught at Ottawa area universities, and he hosts a YouTube program that is viewed by more than, believe it or not, has been viewed by more than 11 million people. So welcome, Paul. Emergency action, which is what we're all about, requires boldness. And the Climate Emergency Forum has not been shy in talking about big, bold ideas for the past few years. Today, however, we may well be breaking new ground, or perhaps I should say, breaking new ice, as we have with us three of the key participants in one of the most boldest and most audacious projects imaginable to address the climate crisis. And they are part of what's called the Seabed Curtain Project, an effort to investigate the feasibility of erecting a seabed anchored curtain adjacent to the Doomsday Glacier, otherwise known as the Thwaites Glacier in Antarctica. As befits a project whose origins and fieldwork span the globe, our three guests will be coming from Norway, Finland, and yes, believe it or not, the coast of Antarctica. Yes, and you have that right. So I couldn't be more excited to introduce our guests, and then we'll get on with this extraordinary program. First is Marianne Hagen, who is the co-lead of the Seabed Project, affiliated as she has been with the Norwegian Institute for Water Research, with a distinguished background in strategic communications, politics, and sustainability, including serving as a former Deputy Minister of Foreign Affairs of Norway, head of communications at the Royal Court, and advisor to the CEO of the Norwegian Ship Owners Association. She brings extensive experience in government relations, stakeholder engagement, and board level experience, an extraordinary background. Next, after Marianne, will be John Moore. Hello, John. John, you are the founder and co-lead of the Seabed Curtain Project, as well as being a research professor at the Arctic Center of the University of Lapland in Finland and a member of the Finnish Academy of Science and Letters. You're a renowned glaciologist with a focus on ice sheet dynamics, sea level rise, and climate interventions. And you're more than an armchair glaciologist. You participated in numerous polar expeditions, including 6 to Antarctica, and you've authored over 200 peer-reviewed articles with more than 21,000 citations. Your work has pioneered bold ideas for glacier conservation, making you a leading voice in exploring feasible responses to rapid ice loss. And last, and directly from Antarctica, is David Holland. I'm so thrilled you're here. You're a professor of mathematics and atmosphere and ocean science at New York University's Courant Institute. You're the director of the Environmental Field Dynamics Lab in New York City and director of the Center for Sea Level Change at NYU Abu Dhabi. You're a leading expert on polar ice-ocean interactions and sea level rise, and you too have conducted extensive fieldwork in Antarctica, including multiple expeditions to Thwaites Glacier. And you are looking at almost every aspect of what's needed to address the climate crisis in the continent of Antarctica. As always, after our conversation, we'll present some of the top climate headlines from recent days, so I hope you'll stay with us to the very end. So first, let me welcome Marianne. I had the pleasure, Marianne, of meeting you in Cambridge at the Cambridge University Conference on Polar Interventions. And so my question to you is, what kind of problem or what kind of dilemma or situation is the world in that could justify attempting to do the kind of research to, is it fair to say, literally hold back nature if it's successful in perhaps the most inhospitable and remote part of the world? Marianne, tell us.
Thank you so much. And thank you so much for having us on your show. And you ask a very good question. Before I get to that, I just want to say that I watched your show on the ongoing discussions in the scientific community about climate interventions. And I noticed that Paul didn't leave our project much hope. So my hope for this hour is that this could be the start of turning Paul around. So I started out even more skeptic than Paul was to our project and towards climate interventions in general. But however, I have kind of lost faith in the world's capability to reduce emissions at the speed needed. So when I was introduced to the Seabed Curtain idea, I just realized that this could potentially mean an enormous difference to the next generations. I want to emphasize that I am convinced that the emissions will come down eventually. And I think that the acceleration of the solar energy worldwide justifies my conviction in this perspective. But there is a huge difference if we have an intact cryosphere when we get to that point, or if the cryosphere has collapsed or started to collapse. So the basic idea of the seabed curtain is that it could delay the global sea level rise by delaying the melting and the collapse of a few specific glaciers in Greenland and Antarctica. And as you said rightly, the main goal is the Thwaites, or better known as the Doomsday Glacier. And it bears that name for a reason. Then Thwaites represents more than 65 centimeters of sea level rise. That is more than 2 feet. But the most important part with Thwaites is that it's kind of functioning like a cork in a bottle of champagne. And if the cork goes, the rest goes. And the ice mass behind Thwaites represents almost 3 meters of sea level rise. And I think we all agree that the sea level rise is the most damaging consequence of climate change, with costs projected in the trillions in this century. If you start thinking about it, just consider the stressed infrastructure in coastal megacities around the world. You have the low-lying regions like Bangladesh, parts of China, parts of India, Florida, and New York, all facing partial submersion. You can imagine the hundreds of millions of refugees and migration as a consequence of this. You can imagine the saltwater intrusion into coastal farmland, destroying food production, disrupting food production, and massive hits to port structures and real estate values everywhere. So, and just as we are speaking, New York City and New Jersey alone are investing $7 billion in coastal protection. So to answer your question, to me, it makes sense to see, is it possible, is it feasible, is it doable to delay 65 centimeters for everybody by doing one intervention in one specific place once that doesn't require any energy running, and that would benefit all. And when I realized that, that's when I called John to offer my help.
And there we are.
There we are.
Well, I wish you luck. I don't know if it's more difficult to tame the Thwaites or to change Paul's mind, but I guess we'll see as we move on. But in the meantime, I'm thrilled to introduce again and turn it over to John Moore. I just want to say, John, I'm familiar with some of your work. I'm not a scientist, so I usually stop not long after I read the abstract, but I know you focused also on really important subjects like, can solar radiation management address the AMOC, the North Atlantic currents, and so forth. And I'm sure we'll probably like to have you back to talk about some of those other issues, equally important. But today you're the founder, the co-founder of this important project. Tell us a bit about what the project is and how you got involved.
First of all, I want to just maybe take a bit of an issue when you said that somehow we are attempting to fight against nature in putting this curtain there. In fact, nothing could be further from the truth. We're actually trying to work with nature's natural mechanisms, but just to sort of give a helping hand to the kinds of situation that has existed for millennia in Amundsen Sea area in front of Thwaites Glacier, and has only in relatively last few decades started to react to this massive geoengineering project that mankind's been doing for 200 years, which is, of course, emitting the greenhouse gases. So, what that has done globally is raise the temperatures of the deeper layers in the ocean. And I'm talking about waters perhaps 500 meters and deeper. These are things that take a long time to warm up. And they sit outside of the continental shelf of Antarctica and are gradually overflowing this kind of edge of the bathtub, if you like. It's like they're being sloshed over the side and going up towards the glaciers. And back in 2016, I was looking at someone giving a lecture in Cambridge at a different meeting to the one that you met us at, Herb. But it was very interesting. There was a cross section of the fjord of Ilulissat and Jakobshavn Glacier, Cermak Kuliak, as it's better called in Greenlandic. And this is the fastest glacier in the Northern Hemisphere and the largest contributor to sea level rise in the Northern Hemisphere at the moment. And this glacier carves into a deep sill that's about 40 kilometers long. But at the end of the sill, opposite to where the glacier is, there's a lip, a sill in the fjord. And outside, there are warm waters from the Atlantic Ocean that are rising up and up and up until they're starting to overflow this lip on the bathtub, if you like. And I saw this talk and I thought, oh, what a pity that this sill is not just a little bit higher. And then those warm waters couldn't overflow it. So this is a perfectly natural geological feature that has allowed this very important glacier in Greenland that is world famous for the icebergs it produces and the richest single fishery in the whole of Greenland is because effectively nature has put a curtain in front of it. So I thought, can we just raise this up and see if we can delay those deep waters going in and keep that fjord cold, keep the ecology as it is at the moment. So from there, I started to look at where else might be a suitable place. And there are not that many around the world because what we're looking for is not a glacier that is just melting because it's sitting in a bathtub of water. That's not the problem. What we're looking for, as Marianne said, is ones that are acting as a cork in the bottle. And if you remove that cork, it lets a huge mass of ice flow out from it. And there's literally only a handful of such places around the world. And Thwaites Glacier is the most at risk. That's the one where we know, according to the computer simulations that everyone's been doing, it's the closest to being unstabilized so that it will be unstoppable by any of the control knobs that we are used to thinking about, like global temperature or CO2 concentrations or anything like that. It becomes like a ball rolling down a hill when you let gravity take control of it. It's essentially just sliding down under gravity. Doesn't care about greenhouse gases, doesn't care about stratospheric aerosol injection or any of the standard methods that you might be able to do. But what it can do is be slowed, or the rate of melting, the rate of thinning of the ice could be slowed if we can stop some of that warm water from reaching that glacier. And the simplest way seemed to us to be just let's raise up the sea floor to make a sort of artificial feature in the subglacial bathymetry that stops that warm water. I'll leave it there for now.
Okay, You make it sound so simple, of course. And which I guess is important in terms of communicating what I'm sure will be and is a very complex effort. Thanks so much, John. Let me turn it over to David. Many of us, when we're on Zoom, we have these kind of artificial backgrounds with, the seashore in Hawaii or skyscrapers. I think it's fair to say yours is not artificial. So, in the course of your comments, David, tell us where you are and what's behind you, and hope we haven't kept you, chilled as you're waiting for all of us to finish there in our warm apartments all over the rest of the world. So, David, so delighted you're with us. So appreciate it. I know how busy you and your 40 colleagues or so must be on the ship right now. So the floor is yours.
Well, thanks for having me on. It's great to meet you all. I've enjoyed watching your past podcasts, and particularly enjoyed the one you had maybe September, October, talking about the Seabed opinion piece. I found that really refreshing, and that's how I kind of saw that you were kind of connecting a little bit with us. So starting with skeptics, I would argue I'm more skeptical than Paul, and that I'd be the first to jump ship with Marianne and John, not this ship, but figuratively. But when I first met Marianne and she explained what John was talking about, it took me nanoseconds to realize that this was something to research. I've spent my life studying sea ice in Canada. I did my PhD in McGill decades ago. And when I did it, not a single person on Earth said the Arctic sea ice would ever change. I remember that distinctly. And then a few years later, the thing fell apart. No question, CO2. And so now I turned my attention to ice sheets because I find this really fascinating, this part of Antarctica. So I'm fascinated with it. And it is so beautiful and so special to be here. It's undescribable. When you see all the birds and the seals and the ice barriers and the bright days and the storms, it's truly a gift to be here. What it is that it is exactly as Marianne and John said, it's a reachable goal. It's not I wouldn't say crazy ideas. I like all ideas, crazy ideas, throw them out there. Let's see where it goes. But this idea seems possible. Now, about 6 hours ago, what we're doing here seemed impossible because 4 years ago, we tried to get into this sea and Amundsen Sea, and sea ice blocked our way. We're on an icebreaker. You can only cut so much. I'll show you later. You'll see a diagram of our path getting here. It looks like the captain was drunk. I mean, we cut so many ways to get to this ice. And finally, with satellite imagery, we found a break and we've darted in now. We're about 200 clicks from Antarctica that way, Thwaites Glacier over the horizon. And we're in a giant polynya, meaning open ocean, where no sea ice, the wind blew it away. So here we are now, we really have a crack at doing this. The spot where John described, if you will, from the ocean, several hundred clicks that way to the north to this way, I'm pretty much over now a trough in the seafloor, like the Grand Canyon. And there's a bump on it called a moraine in the middle. There's 5, but there's one key one, and it's about 20 clicks that way, just right next to me. But just over there, also at the moment, unfortunately, it's covered in sea ice, so we cannot get to it. And you'll see that in the satellite image. We're hoping that in a month, when we come back from there, we get back here on our way home, we're hoping that sea ice will have moved and we can deploy robots on the sill that can monitor the ocean properties, the currents, the speeds, the temperature, and the salinity. The primary reason we want to do that is we want to understand how warm water from the big ocean, Southern Ocean to the north, how does that warm water get here, at what rate, at what volume, at what speed? So our primary goal ultimately is to forecast, in this project, the future of Thwaites. So if there's no problem, then we'll all move on. We'll just go to the next thing. If there is a problem, which is quite possible, if not more than quite, we will do virtual modeling and we will try to figure out, as John described it, how we might block or redivert or divert this warm water. So that's the goal. We have a lot of oceanographic instrumentation. We'll be putting it in the sill, in the canyon. And in 2 years, we hope to get back But I have to stress, this is on a knife's edge. We are at the edge of the possible here and very close, more close to failure than success at all time. It's just extremely difficult. When we get to the glacier yonder, we're going to drill a hole through it about 1 kilometer deep, put down more sensors, fiber optics, and then we're going to observe the warm water that gets to the trough, how it finally reaches the glacier, touches, and then melts it. It's melting it at an unbelievable rate, unsustainable. It's melting it in places at 100 meters a year from the bottom, not 10 centimeters like the rest of Antarctica. It's orders and orders of magnitude more because the warm water is funneling in. That glacier, Thwaites behind me, as we pull up to it later today, that glacier is right now sitting on a ridge, a seafloor high, and it's holding it in place. But after that, there may be no more ridges except until we reach the south pole of the planet. So all of that ice in Thwaites will just pour into the ocean with nothing to hold on to it. That's the worst case scenario. That's the dark scenario. It could happen. And so that's why we're doing the research, is to find out, can we get data? Can we forecast that? But can we also begin to think about solving it? I'm always giving lectures, and until I met Marianne and John in that, the lecture always ended people asking me, what are we going to do? And then they would say, should we turn off lights? And I'm like, no, don't turn off the lights. We don't need everyone in a dark room. There's got to be a better way for the planet. So yes, let's reduce carbon. Absolutely. We're struggling to do that. But let's focus here and now on thinking about solutions. We have lots of people with lots of bright ideas and capabilities. So let's find out if we can do this, because for a small thing, as Marianne and John said, for a small intervention, this could have global consequence. But again, I stress, let's talk about reality, weather, funding. Like last time we had a US icebreaker right next to us. It's not there now. That's gone a few days ago. It's canceled, right? The Palmer icebreaker is gone. We, the US, have very little to no presence here to be able to do anything. So we are struggling to get this research done. We will push through, and I think it's really worth it in terms of the possible payoff.
Thank you, David. That's, I sort of get shivers, no pun intended, just listening to you in terms of the challenges that face you and the potential payoff. And of course, the uncertainty. What you're basically saying is we don't know yet how fast this is moving, how stable it is or it isn't, though you did say it's losing considerable, like multiple amounts greater than the rest of Antarctica in terms of ice loss at the base. With that, just one comment I just want to say, first of all, those of you who want to follow this, go to the Seabed Curtain website, and also those of you who have access to the New York Times. There is a New York Times reporter on board, and he interviewed you at least once, probably more than once, David. Follow his posts. They're really fascinating, and I'm sure there's probably other media. So I think that's the good news, is that the world is sort of an eyewitness, if you will, to what you're doing, unlike many previous expeditions. And with that, I'm sure that Paul is so eager to engage with the three of you. So I'm not going to take any more time. I'm going to turn it over to Paul, and the floor is yours.
Thank you. Well, David, I'd love to be there. My recommendation is play poker with the two journalists on board. Make sure they're best friends, and they can communicate as many of your ideas and thoughts about climate and ice and stuff to the world. I mean, that's your avenue to the world. And Marianne, I didn't realize I had a reputation for being skeptical. I reserve the right to be wrong. I say lots of different things, and I'm often wrong, and new information comes along, and you reevaluate things. I think a lot of skepticism might be from lack of knowledge on what you're trying to do. Like, I guess the biggest concern I would have is the scalability, and do the sills actually, that presumably they move, they're not in a fixed location, so they slowly move over time as the ice retreats and so on. And the anchors, and I'm interested in sort of the anchor. So you anchor the reinforced fabric, tensile fabric, and you have a buoy, or some flotation device at the top of the fabric to hold it tight. If you have a very heavy weight to anchor and a very high buoyancy, it can pull the fabric very tight. because I was wondering about how it would be possible to withstand the ocean currents to do its job. So those are sort of technical questions, which I guess you'll be measuring, with your moorings, right? You're doing two moorings. Is there a helicopter on board that you're flying to the surface of the Earth to do the hot water drilling?
That's the whole key to it. This Korean ship has two helicopters on it. I don't think any other nation has that. This is the dream ship. This is the ship that can do it all.
Okay, and you're going to drill through the ice with the hot water drill, and you're going to put in a fiber optic cable. I've worked with these cables. My background is optics. So it's a distributed fiber sensor, so it allows you to send pulses of light through the fiber and determine properties like temperature throughout the whole length of the fiber all the way down. And you're going to presumably go right down to the seafloor. Once you're through the ice, you'll go right down to the seafloor. So your fiber can relay all that data to you. I know it's all very early in research, but do you have any idea I mean, have you identified a material for this tensile fabric? Because that's the key to everything, I think.
So the quick answer is no. One thing that we kind of have decided on a policy level is that we are going to avoid plastics, just because we think that's going to make it impossible to get the project accepted, because there's enough plastic in the ocean as it is. We are working with an engineering company, Aker Solutions, and they have some thoughts. They have been looking at the materials that we use for old sail ships before we found the oil, to see if there are any of those materials that are natural that can be, put to new use and produce something that's really, really light and durable. Another way to go could be, a lot of people are talking about seaweed and finding new purposes for seaweed, which is organic, obviously, and also a carbon sink. So maybe that is a possibility. And then a third, absolutely different direction could be to collaborate with like MIT to see if you have some nanomaterials, something really built for purpose that doesn't exist yet. But the phase that we are in now is not focusing on the material. We all started with the material because that's kind of super interesting, but it's also not necessary for the phase that we are in now, collecting the data from this point all the way to Thwaites to get the whole lifespan of the warm water going into the ice, and then doing the modeling. That will be the next phase, to put in a virtual curtain to see, will it help? Will it change the temperature? And when we know that with some certainty, then we can start on the engineering work. It's necessary to do that, middle step before we start. But talking about materials, if this project ever gets to that point, which we hope will not be necessary, but if it's necessary, the engineering will help us. There has to be a production line for this material at this, large quantities that we need. So that's going to be a whole line of development.
A whole separate issue. And you would presumably, with the modeling, you could also model what was going on with Greenland's largest glaciers as well, right? You talked about, I mean, this work is in the Antarctica where the ship is, but you've also looked at Greenland. I mean, yeah, it's crazy. Like a couple meters. There's so many cities along coastlines that are, and it's the inundation of the salt water on fertile cropland. I mean, it's just, and the rise could be large if Thwaites was to go. I mean, it's well named the Doomsday Glacier. So anyway, yeah, I'm all for research. I just think that the scalability, and is it going to be durable enough to, like, what are the ocean current volume flow rates down at that? And also that's all changing because of sea ice. I mean, since 2015, sea ice has dropped off a cliff in Antarctica. So that's kind of changed the game, right? It's actually, we've lost more sea ice in Antarctica even than in the Arctic. Just what we lost in the Arctic in 4 or 5 decades, we've lost in Antarctica in like a decade or so. So that's a big factor. So I guess, is it going to work to have something in a fixed location? Because the glacier ice is receding and moving and stuff. So I guess, you say a temporary reprieve. I mean, you're talking about buying a decade for other techniques to slow down climate change?
I think when we're talking about this sill in Thwaites, or in Pine Island Trough, It's a different scale to the ones in Greenland, which are in fjords maybe 5 kilometers across. Here we're talking about relatively small gradients, so it's a very broad sort of feature. It's not something that's going to change on kind of decadal timescales. It's going to suddenly change. It's a sedimentary deposit that's there, which actually helps in terms of providing engineering anchor solutions compared with a hard, igneous bed basement that would require more sophisticated anchoring and work with more complicated submarine tools, etc. But of course, we have done calculations on the data on currents and densities, which together provide a force that has to be balanced by a buoyancy factor in the curtain. I was actually very surprised that both this the static load caused by a differential in density between the sort of saltier water on the outside and the fresher water with the glacier melt, and the dynamic force of the currents flowing in the trough are manageable by very common materials. For example, normal 6-inch diameter fiberglass pipe has sufficient tensile strength to support a curtain up to 200 meters high. And of course, you can have far more sophisticated materials. I mean, you can have stainless steel tensioning cables. You can position the buoyancy in very sophisticated ways, not just at the top of the curtain. The engineers have lots of scope when you think about how aerodynamics works with cars, etc. In a sense, we were wanting to do something almost exactly the opposite with the ocean currents. We're wanting to create a lot of mixing from a small footprint of a curtain because we want that warm water to dissipate its heat before it gets all the way into the glacier. But yeah, the engineering with the limited data that we've got suggests it's perfectly tractable with standard materials. You don't need unobtainium in any way for doing this at the moment.
Would you have any capability to move the curtain if needed? I mean, the grounding line retreat was 14 kilometers in 30 years from 1992 to 2021, right?
Yeah.
14 kilometers. So if you put in a curtain, you have to move it in a decade or two.
The curtain is going to be basically where David is talking
Right.
about, which is
Okay.
200 kilometers away from the glacier.
Oh, it's that far from right. Okay. Okay. So
That's
14
the whole point.
kilometers. Who cares? Right. Right. Okay. I missed that point. Okay. Great.
I can understand why that might be confusing. I've
Yeah.
seen other YouTube's videos
Okay.
of a curtain surrounding Antarctica, for instance, and that's not the case. It's
Okay.
just enhancing the surface far away.
Yeah, like I say, I reserve the right to be wrong. So you're doing the measurements on the sill and then right at the grounding line.
Exactly as Marianne described, the ocean is several hundred kilometers north of me. I'm here mid-sill on the continental shelf break. In the trough, the sill is just over there under sea ice, and back there is the grounding line. And so it's that canyon that we described. And one of the other issues we'll be dealing with and thinking about, of course, is icebergs. Both the threat to our moorings is significant. Icebergs remove everything in their path. They tend to be
the seafloor.
Yeah, they scour. And so that's a major problem. The other thing is, if you think back, kind of the visual of the collapse of the Laurentide ice sheet and the armada of icebergs that poured into the North Atlantic, leaving rocks all over the ocean floor, the Heinrich events, no doubt there'll be an armada of icebergs coming north. I suppose a lot of them will get trapped on these moraines too. So there's complexity to it, which is interesting from my point of view. And there's also another sleeping dog. This is called West Antarctica, and it's largely a marine ice sheet, meaning this ice sheet is largely below sea level. But there are significant portions of East Antarctica that lay sleeping that could wake up and could be far bigger problems. The essence of that, it took me a long time to understand it. But basically, if you take a computer model of our Earth and you simulate Earth, atmosphere, ocean, and our climate without greenhouse gas, it does a certain thing, and it kind of looks like it did 100 years ago. It's truly mind-boggling and almost not really understandable, but you can look into the model and see it. that when you put greenhouse gases, it affects the winds around the tropical band of the Earth. That sets up planetary waves that change the winds here in the Amundsen Sea. Those winds drive the water I'm floating on here, this top 100 meters of cold water, it drives them out to sea, and is projected to do that more and more over this century. And so that's where the concern lies, and then the warm water pours in. So it is a fact that greenhouse gases change the wind here. And I was the last person to agree with that until my PhD student proved it. He published it in Nature with me. And it was like, that is not possible, but it is. And it's a complex system.
Right. And that change led to the collapse of Antarctic sea ice starting in about 2015. Before then, it was growing about 1% a decade or something. Yeah. You mentioned there's 5 sills. Would you want to put the mooring on the highest sill, or is that the idea? Or just midpoint, sort of?
Yeah, my understanding, I saw 5 sills in a scientific publication, and we'll go for the tallest.
Okay, I'm just wondering, how high are they up above the seafloor, I guess?
Out of the continental shelf break up there north, 300 kilometers, the shelf break is about 600 meters deep, but there's a little dent in it for the trough begins, maybe 100 meters. And then where I am now, we're down to about 800 meters of depth. And then the sill rises to come up to about 600. So can you picture it? You go from far north, 600 downhill, sill, a couple hundred meters. And on the other side of me going that way, you're going to drop down to 1,400 meters by the time you hit Thwaites.
Can I just say one thing about the engineering work? And we are working with this Norwegian, or it's a global company headquarters in Norway. One of the many reasons that I become kind of optimistic about this project is that these guys and girls, they're used to working on 3,000 meters depth with ocean water, and then they go 3,000 to 5,000 meters lower to find the oil, and then they drill sideways for 5 kilometers, and then they hit something this big and then connect with something from the other side. And these are also harsh conditions. So this is what they do every day. If you disregard the ice, which is obviously very, very difficult, and the location in itself, the depth is not that difficult. 650 meters, that it's possible to do things at 650 meters depth.
It sounds like deployment of the curtain by a submarine would make more sense, probably. If you ultimately get all the materials and everything, that could be done. You know, a small submarine that they use all the time on oil rig work.
We assumed that we would actually need 5 icebreakers to work there for a decade, that you would need 10 ice-strengthened support ships that would carry the curtain elements and then would be semi-submersible, for example, and they would be unfurled at depth and attached with these remote operated vehicles that the oil industry, which is kind of ironic, they're in a way the people to blame for the problem, but they could actually have the skills to help us out a big time as well.
Right. Also, I mean, China's building a dozen icebreakers or something as we speak, so you might want to start talking to them about the project as well.
There'll be one here next week, right next to us, China.
Let me just segue a bit away from the technology, where Paul and you all are masters, to the question of the big question, one of the many big questions you'll be wrestling with, and you already are wrestling with, and that's governance. So let's say that your research over the next few years leads you to conclude that, in fact, this dynamic change is and will threaten the sea level rise in multiple meters within the lifetimes of people alive or the next generation. And then what does it take to get to yes? Is it a resolution at a COP? Is the IPCC involved? Is it the UN? Is it the countries that are parties to the whatever treaty that I'm not familiar with that governs what happens in and around Antarctica? Is it something I assume that you're looking at or have looked at and will continue to look at very closely? So anyone, Marianne, or anybody else who wants to take a shot at that?
Your point is on the dot. It's the Antarctic Treaty System that will have to make this decision. But John knows a lot about this as well. But from our perspective, it's not the goal to pass this, by as few nations as possible. Doing any kind of climate intervention has to be broadly accepted, understood, and sanctioned. it's easier not to go to the UN because it's very difficult these days to get the 193 countries all saying yes at the same time. But we want the debate about climate interventions and this intervention proposal to be as wide and involve as many people as possible before you get to a final decision. John, you want to say something more about the process?
I think that it's important to bear in mind that Thwaites is the big one. So, in a way, that's the sort of final destination that we're looking at. It's not the starting step. Basically, you could say the road to Antarctica goes through the Arctic. It's 1,000 times cheaper and easier to work in parts of the Arctic than it is in the Antarctic. But obviously, the Arctic is governed very differently from the Antarctic. There are indigenous and local peoples there, and anything that's done there can't be an excuse for some neo-colonialist kind of, oh, it's for the general good and you just have to suck up some bad things, as the Arctic peoples have had to deal with throughout their history. There has to be local benefits, considerable local benefits. And that's most definitely true in the case of Greenland. We've talked to Greenlanders about this extensively already. It's clear that local people do not want anything that harms the very important traditional activities of hunting and fishing, as not just purely from the livelihood perspective, but also because it's a vital part of their way of life and how their identity, you could say. But equally, most of Greenland is not inhabited or closely fished by local peoples. So there are potential, if you like, starting points where a curtain might have benefits for local people and some modest value for sea level. But just to put it in perspective, even if we forever prevented 1 inch of sea level rise by building something in Greenland, that would allow Greenland to be able to forego the Danish support that it has and achieve independence for them. That's what 1 inch of sea level rise, not 1 inch per year, but 1 inch in total over the next few hundred years of avoided sea level is worth to the planet. So there are very big incentives. I always call the Greenland ice sheet Greenland's icy treasure, really, because it's worth actually far more than any rare earths or other mineral resources that are existing at the moment. And of course, ironically, this is the better preserved and covering up potential mineral deposits. It just has to be recognized by people that it's a vital global resource to keep this ice sheet intact. And of course, it isn't at the moment recognized. There has to be some, I think, some pathway where, like the Amazon rainforest, the ice sheets are recognized as global goods that should be protected and supported by the planet everywhere else that benefits by having them not melting.
That reminds me, John. I think it was at the last program we recorded. At the end, I give some headlines on climate, and my recollection is there was someone or some nation or some group that recently proposed that ice be given the status, personhood status. And I don't remember where that came from. I don't know if any of you have heard of it.
Yeah,
But
I was there, and it was in the Polar Law Symposium in Greenland. And it's a similar idea, like the Ganges River has been
exactly.
granted personhood. I think this is the great thing. You need experts and in all different kinds of fields. And I find it very gratifying that a lot of legal scholars are really interested in this, and people have their own perspectives to bring, and they're very important.
Yes, I guess without getting into geopolitics, I guess we have to hold our fingers crossed if that's the right way to think about it in terms of the future of Greenland and whether it remains under the jurisdiction or becomes independent as opposed to what some other people have in mind for it, apparently from rumors that I've heard David, let me get back to you. I'm curious. So there are, as I understand it, you've got 40 colleague scientists, I assume the cream of the crop, the best, the brightest, the most dedicated from all over the world, coordinating and working on their own individual and group experiments. But as far as I understand it, you're the only one that's essentially representing or has the dimension of the seabed curtain as part of your remit. And in your conversations over beer or whatever, what do your colleagues think? Are they as skeptical as you were? Are they sort of shaking your head and wondering, whether you've had more than one beer, or are they sort of intrigued and supportive of this idea, recognizing, of course, that this is in the the exploratory phase and certainly not a decision.
We don't talk about it because that's jumping the gun. We are so busy here. We have 6 work teams. We have seal tagging to get temperatures on the seals, to get the broader Amundsen Sea picture. We have helicopters with huge radars flying to get the ice thickness. I'm doing the mooring stuff here and downstream. And we have other innovative machines to try to get data. So right now, everybody's in work mode. It's like, where is that missing screw that holds the bolt, the thing to the helicopter? Where is it? Do you have that? Because I don't find it anywhere. So that's what it's all about. Is where is everything?
You don't have
So
the luxury that we have, the armchair activists sitting in our comfortable apartments around the world. You're out there, as we literally see. I'm going to ask one more question, and I'm going to turn it back to Paul. I always like to ask this big picture question, and that is, if all of us are fortunate enough to be around in, say, a decade or so, when we reconvened, for each of the three of you, give us your sort of very briefly your most optimistic take looking back from 2035 in terms of what happened with your project and what happened more broadly, and maybe if you're interested, what's the other side look like, the most pessimistic sort of prognostication.
First of all, I would say that regarding the pessimistic alternatives, there are thousands of ways everything can go wrong. I don't think that's very interesting. The interesting thing is finding the golden path. That's the skillful thing. Over the decade, I would like to see us having a lot of progress made on understanding when Thwaites might collapse by collecting this kind of data that David's doing now and having improved models. But I would also like to see much more willingness to face up to the reality that if it looks like it does today, that Thwaites is not going to be stoppable by reducing our emissions, then there needs to be a lot of research done on what might we do instead, not only in Antarctica, but also in Greenland. The polar areas in general need far more people working on it. In a way, people have forgotten how it was 50 years ago when Greenland played a vital role in the Cold War. There was essentially an American army on Greenland. The level of infrastructure people have forgotten that could be thrown at something that is in large degree an existential risk, but at the moment is just being treated as a sort of interesting little research thing with no direct relation to humanity, but it really does.
Well put. I think I could say we're proud at CEF that we have focused considerably many of our resources on the poles. We honored Peter Wadhams, who has appeared on a number of our programs recently as one of our giants of climate, and did a program where he talked about retrospectively his career over the decades in polar research and so forth. So we certainly, at least I believe I'm speaking for everybody, we certainly support what you're saying in terms of the need for the world to turn to the poles with resources and attention in ways that we haven't been. Let me ask Marianne, what's your sort of grand positive scenario, and what might be a downside scenario a decade from now?
If we could say 15 years instead of a decade, the worst case is absolutely clear, and that's that the science tells us it's too late. It's unstoppable. Worst case. Best case, research shows us we don't need it. That's the absolute best case. We've done everything. Emissions are down. We found the methods to withdraw carbon dioxide from the ocean and the air. We don't need it. Best case. And our mission is if if it's not too late, we want to present the next generation of decision makers with the recipe. This is how you can do it. This is the science, this is the legal framework, and this is the technology. This is the engineering solution. Please have it. I hope you don't need it. If you need it, this is the way to go. That's our mission.
Well put. And what strikes me from what you're saying is that the one thing that the best case and the worst case have in common is we don't do it, either because it's too late or we don't need it, ironically. So it's in that intermediate zone where intervention can actually make a difference. And the only concern I have with what you're saying is that I would propose that what I hope you would consider a friendly amendment, which is to give the information not to the next generation, to this generation of decision makers, who then may choose to pass it on to the next generation. But I don't know that we have the time to necessarily wait to the next generation. Let's hope we do, and I'm wrong. And let me turn it back to David. David, for your wrap up from the ship there at the edge of Antarctica, what are your thoughts?
I think the world changes on a decadal timescale. Even a decade ago, there was this idea of climate denial or whatever that was all about. That's gone. We would have meetings and people would talk about climate. Like, we don't do that anymore. Move on. So right now we're talking about climate interventions. I would think in a decade or 15 years, we won't be discussing whether or not we should be doing this or not. We'll be much more advanced. And as civilization goes along, over centuries, we're going to face some major problems. So I think geoengineering is here to stay, however you want to phrase it. This conversation will look different in 10 years in terms of, is this something questionable? So the second thing is, how do you pay for all this? Is right now we have kind of governments leaning in and leaning out. I think that's a huge mistake to have government involved in this problem. We need people, societies. We need to solve this. There is a lot of resources out there, a lot of funding and skills. This is too much to leave to a government decision, is my view. And the third thing is, this is very difficult and dangerous. 6 people I know have died in this arena in the last decade. And you see them at a meeting and they're not going to any more meetings. So it's very dangerous, and we need to move towards automation and robots and vehicles and that kind of thing. And I think this way we're doing this will look different in 15 years as well.
Thank you for all three of those very fascinating and diverse perspectives. And let me give Paul the final word.
Just a quick second, because I don't want to run too long. But John, you were talking about infrastructure on Greenland in the Cold War. Yeah, the Americans actually had a nuclear reactor underneath the ice, and they had rail line going all over underneath the ice. The idea was to carry missiles that couldn't be tracked. But of course, the ice moves and all the rail lines and passages were shut. So the project ended, but parts of stuff are still, of course, under the ice, probably some being exposed. It's always good to look at the history when we're talking about projects. David, last thing for you. You mentioned 6 teams. I guess all of the scientists work together on like tagging penguins, and then you move to the next thing and the next thing in each of the teams. With all that cold and fresh air, you probably all go to sleep at like 7 p.m. or something, right? There's no time for revelry. And I mean, you're just exhausted after the day's work. I'm guessing that's sort of the way it is.
Yeah. And the reprieve is once a week. The Koreans put on a fantastic barbecue. So that's kind of the highlight of the week. But basically, it's 24/7 sunlight. And it's a lot of lights. It's a lot of work, but it's extremely rewarding. Nobody here is complaining.
Thank you. And, it just strikes me, I don't have a lot of connections with Antarctica, but a few of us, in fact, all of us on this call from our end, were at the COP in Azerbaijan, and we had an opportunity to meet with Heidi Silvestri, the glaciologist. She attended one of our programs. I recently saw, following her on LinkedIn, that several weeks ago, she hit the South Pole as part of an expedition as the first woman ever to get there by kite skis or ski kites or whatever they are. So that sort of gave me a little bit of a shiver that I'd gotten to meet her in Baku, and she and her colleagues were doing that incredible thing. I guess you probably know her or know of her. And so I wish all of you, as you said, David, it's dangerous. It may sound like a cliche, but I can't express our admiration enough or as strongly for your dedication, all of you involved in this team and all the other teams that are putting your neck out and risking your lives, and some cases your reputations on what might be perceived as a crazy idea. I think I speak for CEF. You have our support. We hope you'll come back next year and give us an update. And again, it's so much of our thanks and appreciation for all the work you're doing. We'll be thinking of you. We'll be supporting you. Well, after that remarkable discussion on the biggest and boldest project proposed in Antarctica, I'd like to give a brief summary of some of the headlines on climate that have occurred in the last few days since we last met. First is that there was a new report in India that showed that 9 Indian cities are turning into what has often been called heat islands, where because of all the dark surfaces and concrete and brick and so forth, cities all over the world are becoming hotter much faster than their surroundings. And in India, which is already experiencing scorching temperatures, these heat islands are endangering people. And yet, very few Indian cities as yet have plans to address that. The next item has to do with one of the things that we talk about a lot on the Climate Emergency Forum, and that is how everything is connected to everything else. So we have talked about and had programs on plastics and microplastics. Well, a new report came out showing that the microplastics in the ocean may well be reducing the ability of the oceans to absorb carbon dioxide. So not only are there direct impacts on wildlife in the ocean and ocean health, but it also has a negative impact on climate change by basically interfering with the metabolism of the phytoplankton and the zooplankton. So this is, again, an example of, you can't just look at one thing, you look at everything connected. And in the same vein, there was a report that in Scotland, where they had major wind turbines that were erected offshore, they found that 3/4 of the energy they produced were being wasted. And they were being wasted because they don't have the connections and the capacity yet to connect to the grid. So once again, if you look at just wind turbines, you say, this is great. But if you look at the system, it's not working. A third aspect of good news, I would say, or potential good news, is that China, which has about 15% of the world's total consumption of everything by the Chinese people or so, they've now made a commitment to green their supply chains and to look at carbon footprints for everything that they do within cities and within consumption, with the goal of dramatically reducing the carbon footprint of their goods and services, a significant factor. And given China's top-down dynamic, that's likely to be at least somewhat successful. And lastly, the big milestone was achieved on January 1st of this year in Europe. The EU, the European Union, basically implemented the final stage of what they call their border adjustment tax, which basically requires in certain heavy industries, products that are imported into the EU have to pay a tax or a levy based upon how much carbon is emitted in their production. The goal being to provide an incentive for countries and companies outside of the EU to reduce their carbon so that they don't have to pay as large a levy or a fine. This has been proposed by economists for many years, and we'll have to look closely to see how successful it is in the EU. So those are just some of the headlines. As always, we appreciate your support. If you liked today's program, please like it, subscribe to our channel, go to our website, climateemergencyforum.org. If you see that little donate button, and even if you don't see it, go find it. It's right there. We would encourage you in the beginning of the year and any part of the year to donate so that we can continue to provide the best in climate emergency programming. We've had over 245 different programs, and we expect to do another 50 or so this year, covering every aspect. We're still in the process of developing our schedule for 2026. So please, in the comments, tell us what topics, what subjects, what people you would like to see us bring on board as we develop our program for this year. So with that, let me say once again, thanks to our guests today from Finland, from Norway, and from literally right off the coast of Antarctica, and one of, I think, our most important and exciting programs, and one that we hope to emulate as best as we can in the coming weeks. So with that, as always, we look forward to seeing you next week. Thank you.